I have been very, very happy to see, as of recently, lots of people on YouTube and really across the internet have been using my methods. They've been popping up more and more often, so I'm very happy to see that. I know it's been almost a year since I posted my first video, but we are going to be doing lots of problems with Desmos today. So this will be the first video in a series where I do every single math problem on all the Bluebook practice tests, and so we will start with practice test 4. In this first question, it asks, if x equals 7, what is the value of x plus 20? And obviously, that one is a bit easy, and we'll see that for the very first few, so I can sort of speed through them. But we can do it, 7 plus 20. Or if we really want to get into it, they say x equals 7, and we can do x plus 20. And we're using the x1 because x can't be used as a specific variable. If we do this and this, we just get a line, and we're going to get the answer of 27. But that's sort of weird. Okay. The lists compare the values in dataset X and Y. Which statement correctly compares the mean of dataset X and the mean of dataset Y? This is another one where you probably is faster to not do it with Desmos. I will show you how to do it with Desmos, but I will always tell you, especially with these module ones, I do not recommend it. What you can do is say dataset X equals 5, 9, 9, 13, and dataset Y equals 5, 9, 9, 13, 27. And just compare the means. So mean of x1 and mean of y1. And so we'll see the mean of y1 is greater. But I do not recommend doing it this way. We can obviously see that x1 and y1 are the exact same, except y1 has a bigger number. So the mean will be greater for y1. All right, question number 3 says, right triangles PQR and STU are similar, where P corresponds to S. If the measure of angle Q is 18, what is the measure of angle S? So this, again, is not a Desmos question at all, but like I said, I will go through all the questions. So we will do this one as well. What we're given here is two triangles, and the measure of angle Q, which is up here, is 18. Since this is a right angle, and we know that all the angles in a triangle add up to 180, we know that 90, which is the right angle, plus 18, plus the measure of angle S is equal to 180. And we know that this angle is the same as this angle because they're similar. So this right here is also 18, which is horribly out of scale, but that's okay. So what we can do is we can just say 90 plus 18 plus some angle is 180. And I'm purposely just doing it with the most amount of Desmos, but I think for this one, you can either do it in your head or just subtract off the 90 and 18 from 180 to get the correct answer. But, why not do it Desmos way? It doesn't speed up the problem for this one, but it doesn't hurt it either. A rocket contained 467,000 kilograms of propellant before launch. Exactly 21 seconds after launch, 362,105 kilograms of this protein remained. On average, approximately how much propellant in kilograms did the rocket burn each second after launch? So how much we used, we can figure that out by taking how much we started with, 467,000, and just subtracting off how much we had left, which was 362,105. And if we divide that by 21 seconds, we're left with 4,995 kilograms per second. Question number 5 says, we're given a system of equations, and they're asking what is the value of x plus y? So there are going to be two different ways of doing this one with Desmos, and one clever way. So I'll show all three ways. My least favorite way with Desmos is going to be this way, where you can just graph both of the equations. And when we click the intersection point, that will be our solution. So x is 5 and y is 8, and we can add 5 and 8 to get 13. A bit of a better way, just because it doesn't involve having to look into the graphing area, we'll be making a system of equations in Desmos and going 4x1, comma, negative 3x1 plus y1 equals 20, comma, negative 7. And if you have no idea what I did just here, then go watch this playlist right here where I go over Desmos theory. And then why I like this method better is because we can go x1 plus y1 and we get 13. We don't have to do anything in the graphing area. And then the clever way, which doesn't involve Desmos, will be like this. If we're given that 4x equals 20 and negative 3x plus y equals negative 7, what we can do is we can add negative 7 on both sides of this top equation right here. So what we'll get is 4x add negative 7 equals 20 minus 7, right? But the thing is, we know that this right here actually equals negative 7. So we can just substitute it in and say, really, that 4x minus 3x plus y equals 13. And when we do 4x minus 3x, that just gives us x plus y equals 13. And so the SAT actually deliberately set up this problem like this so that we can solve for x plus y. This is called an implicit solution because we're not solving for x and then y and then adding them. We're solving for the expression they gave us. The expression is x plus y. And this is actually very common. And so if you ever see the SAT asking you to solve for an expression, a lot of times you can implicitly solve it and it will be faster than using Desmos. But either way works. Question number 6 says, a certain apprentice has enrolled in 85 hours of training courses. The equation 10x plus 15y equals 85 represents the situation, where x is the number of on-site training courses and y is the number of online training courses this apprentice has enrolled in. How many more hours does each online training course take than each on-site training course? So we can see the equation says that 10x plus 15y equals 85. And it says that x is the number of on-site training courses and y is the number of online training courses. So 10 times the number of on-site training courses, x, plus 15 times the number of online training courses is the total hours. It can be, reasonably inferred that 10 means the time it takes to do one on-site training course, and 15 hours is the time it takes to do one online training course. So they're asking how many more hours does each online training course take than each on-site training course, and that's just going to be 15 minus 10. Question number 7 says, square x has a side length of 12 centimeters. The perimeter of square y is 2 times the perimeter of square x. What is the length in centimeters of one side of square y? So this problem is testing our proportionality constant, basically. What this means is when we're comparing dimensions of shapes, we have to be very cautious about what dimension we're measuring. So, for example, if we were saying that the side of square y was twice as much as the side of square x, so for example, if this was 24, then the area would actually not be twice, but it would be 4 times the area of x. So a side length is a one-dimensional or measurement, and area is a two-dimensional measurement. And so we have to be very cautious. A perimeter you might think is two-dimensional, but a perimeter is just a bunch of lines added together, and lines are one-dimensional. So because we're comparing one-dimensional measurement to one-dimensional measurement, the proportionality is going to be the same. So because the perimeter is 2 times square x, then we also know that the side length is 2 times the side length of x. So this will actually be 24. Question number 8 says, the given function g models the number of gallons of gasoline that remains from a full tank of gas in a car after traveling m miles. According to the model, how many gallons of gasoline are used to drive each mile? So again, this is not very much so a Desmos question or really a mathematics one, to be honest. It's more of just a conceptual problem. So we can graph it if we want, just to maybe get a sense of what the problem looks like, but it's not necessary. And I accidentally put g of x, g of m. If we want to sort of see this, we can press shift and then drag this in, and we can see a nicer model. So it looks like after driving 0 miles, we have 12.1 gallons of gas in our full tank. But after driving 242 miles, we are at 0 gallons of gas in our tank. That makes sense, right? When we drive a car, the more miles we drive, the less gas we have. So they're asking, after each mile that we drive, how much gas do we use? And we actually look right here, and we see that each time the miles increases by 1, we have to subtract off 0.05 from our gas, G. So the answer is 0.05. Question 9 says, if the absolute value of 4x minus 4 equals 112, what is the positive value of x minus 1? So this one can be a graphing question. And I would caution you from actually using regression right here because of the fact that we know that absolute value questions usually have two solutions if they have a solution. And because of that, we're not quite sure which one they're asking us about. So if we know that there's going to be more than one solution, sometimes it's actually better to graph it. So what I'll do is I'll say 4x minus 4 equals 112. And now when we press this home button and zoom out a little bit, we can see our solutions, but we actually can't click them. So a nice way to be able to click our solutions is to turn it into y equals the left side and y equals the right side. And that's always my favorite way to look at these things. So I'll go ahead and just go y equals this left side and y equals the right side. And now we can click on our solutions. And our solutions are the x values, negative 27 and 29. And when we look at x minus 1, so negative 27 minus 1 is going to be negative 28, and 29 minus 1 is going to be just 28. The positive value is this 28. So 28 will be our solution. Question number 10, we are given that 1 over 7b equals 11x over y. And it says the given equation relates the positive numbers b, x, and y. Which equation correctly expresses x in terms of b and y? So this question is saying if we're given 1 over 7b and that equals 11x over y, they're asking us basically to solve so that x is on one side. And we can do this by hand, but for some of these questions, I actually prefer doing it with Desmos, but not all the time. In this case, it's about just as equally fast to do it either way. So by hand, it would look like multiplying y on both sides to get y over 7b equals 11x, and then multiplying by both sides by 1 over 11 to get y equals 77b equals x. X equals y over 77b. That would be C. And with Desmos, we can do it in a bit of a brute force type of way that works better when we are given more difficult ones to do by hand. So what we can do is set up this equation and we replace the equals with the tilde. We have to make sure we put a 1 when we're using regression. And what we do is we just add a slider for all the specific variables or all the constants that are not x, because we're trying to solve for x. And so we'll just add a slider for b and y. So b can be 2, just a random number, doesn't really matter, and we'll explain why later. And y1, we'll just make it 3 for no particular reason. And so now if we test all these options, a through d, we can see which one x equals. So let's try a first. We'll get 7b y1 over 11. And we'll see that they're saying, the problem is saying that this equals x. And we look at this, 3.818, and we see the actual value for x, and we're like, that's not the same at all. So we can try b. B is y minus 77b. And we can see that that is also not x at all. And so we can try c. C is y over 77b. And we see that this is the same. And why it doesn't matter what these sliders are is because the question is saying that if the expression is the same, which equation correctly expresses x in terms of b and y, that means that the x is going to be the same in the first equation as in the second. So we can make these whatever we want, and this will always be the same in the first and the second. I am making sure, though, that we keep b and y positive. Because the problem says to keep them positive, it is better practice too. The only thing that we can't do is make y1 equal to 0 or b equal to 0. In question 11, they give us a table with values of x and values of f of x. And they say the table shows 4 values of x and their corresponding values of f of x. There's a linear relationship between x and f of x that is defined by the equation f of x equals mx minus 28, where m is a constant. What is the value of m? This is a great Desmos question, and we can just plug in what they give us. F of x equals mx minus 28. And really, since we're solving for only one variable, m, that's all we're solving for, we only need one equation, right? When in a system of equations, we need the same number of unknowns as equations. We need the same number of equations as unknowns. And so when we have one unknown, we just need one equation. So I can go f of 10, right? Because when x is 10, f of x is 82. And m is 11. And we can actually use any of these values. So we can go f of 15 is 137. And we get the same number for m. And we can use any of the 4 values. But we only need one equation. We don't need to add more than that. In question number 12, they give us an expression, and they say the expression is equivalent to bx cubed minus 11. And hidden, that means that those expressions are going to be equal to each other if we plug in any value of x. and it says that b is a constant. They're asking us to solve for b. So in this one, x is not a solution. We're not trying to solve for x. And that's the biggest thing to remember for these types of problems. When we're not trying to solve for x, when we're saying the expressions are equal no matter what x is, right? X is not something that we're solving for. Then what we can do is we use this method, which you can learn more about by watching my second video. We go 5x cubed, and we're going to use 1 because we're going to do a regression. We go minus 3 minus negative 4x cubed plus 8. And we go equals, because they're equivalent, the second expression, bx cubed minus 11. And we can go x1 equals 1, to really the exact number of numbers that we need inside this element list is equal to the amount of unknowns we're solving for, which in this case is just 1. We're just solving for b. But sometimes I like to add more, just in case. And so 5 is it's a fine number. Now, this problem is very easy to do by hand or just by looking at it, right? We can see that when we add the cubed terms, 5x cubed minus negative 4x cubed, we're going to get 9x cubed. But this is a good method for when these types of problems get harder. So I wanted to do it this way, just so we introduce it in a easier type of way before we see problems that look a little bit harder. In question 13, we're told that y is greater than 14, so that's an inequality that we have. And also 4x plus y is less than 18. And it says the point x comma 53 is a solution to the system of inequalities in the xy plane. Which of the following could be the value of x? In this case, we can just use Desmos to write in our inequalities. Y is greater than 14, and 4x plus y is less than 18. And so our solution is going to be where these two intersect, which is going to be in this upper left-hand corner, right? Because when we hide this, we can see that it's going to be in this top part. And when we hide this, we see it's going to be in the left part. So the top left part is our solution. So if we go x1, comma 53, and we test our values of x1 by what the answer choices are, so we can try a is negative 9. So we test negative 9, and we see if we zoom in really far, that it actually is a solution because it lies in the top left part of these inequalities. It lies inside the solution region, but just barely. And if we try negative 5, we see that that is definitely outside of our solution. If we try positive 5, that is most definitely outside, and 9 will be way outside of our solution. So negative 9 is the correct answer. Okay, problem 14 says, bacteria are growing in a liquid growth medium. There were 300,000 cells per milliliter during an initial observation. The number of cells per milliliter doubled every 3 hours. How many cells per milliliter will there be 15 hours after the initial observation? Because we're dealing with a problem that says that the number of cells is doubling or something is happening where it's not acting linearly like a parabola. It's doubling or tripling or some numbers being multiplied by the previous amount. We're dealing with a exponential function. So the standard exponential function is going to look like f of x equals a, which is our coefficient, times b to the power of x, where b is our base, or growth factor. So b is a growth factor or base, and a is our coefficient or initial value. And what we can do is we can say, well, they were initially 300,000 cells per milliliter. So we can just say a equals 300,000. And then another thing we're told is that the number of cells per milliliter doubles every 3 hours. So f of 3 hours in is going to be a except doubled, right? The initial value except we're doubling it. So 2 times a, or just 2a. And now they're saying how many cells per milliliter will there be 15 hours after the initial observation? So we can just go f of 15. And we're given 9600000, which is 9,600,000. Yeah, that's the best way to do this problem. Now, if we didn't know that a was our initial value, you can of course always make this a system of equations and just literally type it in exactly how they tell it to us. So f of 0, when the 0 time in, the initial value is 300,000, and f of 3 is going to be 2 times 300,000. And so that is 9,600,000. Or if we want to get fancy, we can go 2 times f of 0. It gives us all the same result. Now, the reason why I wouldn't do a table for this question is because it gets a little weird. And yes, of course, we could do autoregression, right? And that might look like initially, so at time 0, there were 300,000. And 3 hours in, there was double that, so 2 times 300,000. And we could use autoregression and change it to exponential. And if I wanted it to do it this way, there would be 2 ways to finish this problem. So the first way, if I were to use autoregression with a table, I would press shift and I would slide this way down. And then I would go x equals 15. And I would have to scroll way down, keep on scrolling. And there we go. Right there. And we get 9.6 times 10 to the 11. And that's just really weird to look at. That's so weird. Like, that's, holy cow. Like, that is a long time of scrolling down. Wow. And the second way that is slightly better is going to be pressing this export button, and we change this to f of x, and then we go f of 15. In that case, why I don't like this method is because b, or this base, or growth factor, is not quite 2.71442. They just sort of rounded it off, and so we can see that it doesn't give us quite the right answer. So that is why I don't really like using a table. Yeah, so our original method is just a lot better for this type of problem. In question number 15, we're told the graph gives the estimated number of catalogs Y in thousands a company sent to its customers at the end of each year, where X represents the number of years since the end of 1992, where 0 is less than or equal to X is less than or equal to 10. Which statement is the best interpretation of the y-intercept in this context? So this is a bit more of a conceptual problem than an actual mathematical one. We can sort of see what this graph really means. When we look at it, again, it represents the number of catalogs a company sent to its customers at the end of each year. So we can see that the number of catalogs being sent is less and less every year. So the y-intercept is going to be at the end of 1992, because 0 years after 1992 is just the end of 1992, where they sold 9,000 catalogs. So if we read through the options, A, the estimated total number of catalogs the company sent to its customers during the first 10 years was 9,000. That's not accurate. We're talking about where x equals 0, which is the y-intercept, and that's just talking about the first year. B, the estimated total number of catalogs the company sent to its customers from the end of 1992 to the end of 2002 was 90. That's not right at all. C, the estimated number of catalogs the company sent to its customers at the end of 1992 was 9. That's not correct because it's trying to trick us. We have to be careful because in the very first line it says in thousands. And D, the estimated number of catalogs the company sent to its customers at the end of 1992 was 9,000. That is the correct answer because, well, a y-intercept means when x is 0, and x is the amount of years after 1992. And it sold 9,000 catalogs. In question number 16, we're given an expression, and they're wanted to know, out of options A through D, which expression is equivalent to our original expression. And so there are going to be many different ways to do this one. And I'm going to do the first way by hand, just to show you people that you don't have to be a Desmos fiend for everything. If we go the 7th root of x to the power of 9 times y to the power of 9, because of exponential properties that I won't explain, because you can always find other YouTube videos that explain it better and faster than I might, you can go the 7th root of x times y to the power of 9. And then 7th root just means that you're taking all of this, x times y to the power of 9, all of that, and you're raising it to the 1 over 7th power. And then because of more exponential rules, we can say that x times y to the power of 9 to the power of 1 over 7 is just to the power of 9 times 1 over 7. And then we get x times y to the power of 9 over 7. So this question is very much doable by hand, but we are a Desmos channel, so we're going to be a Desmos fiend. Let's go. And so there are going to be 2 main ways to do this question. The first way is by looking at a graph. So typically in these equivalent expressions problems, I might just set y equal to the expression, but it won't work the exact same because we have y on the right side. So we can still try it. And we go nth root, so nth, and then ROT, nth root, and we go 7x to the power of 9, y to the power of 9. And holy moly, that is one function. So sometimes, let me turn it to purple so we can see better. Y equals doesn't really work, so we can change it to 0 equals, and that doesn't also work. So x equals doesn't really help either. So we'll keep it with y. And then what I'm going to do is test answer choices A through D to see if the expression is the same. Expression is just, the graph. Y equals xy to the power of 7 over 9. That is not the same at all. And so we will try option B. Option B is x times y to the power of 9 over 7. And we can see that these perfectly align. So they are the exact same expression. You might be wondering, how in the world do you know that you're allowed to set y equals to the left side? Well, if the expressions are equal, that means that this right side is going to be equal to the right side no matter what. So really, as long as we ensure that the left sides are equal, and by chance we pick the one, A through D, where the right sides are also equal, that means that the left side and the right side are equal, which basically means it's the exact same thing. So as long as we make sure that the left sides are equal, then we can test if the right sides are equal. So we can choose, 5 for this and 5 for this. And now we're dealing with a hyperbola. Or we can try x for this and x for this. And we're dealing with whatever this thing is. Or we could, we could do 1 over x, right? And 1 over x. But it doesn't matter as long as the left side are the same. And then the second method that you can do is sort of similar to the method we did a few problems ago, where we set a slider for x and y. So I'll just go set random numbers. And then we go nth root, 7x to the 9 times y to the 9. We have to make sure that we're doing x1 and y1. And we see this number. And so what we do is we just test options A through D until we see that same number. So I'll try, maybe the answer is C, x1, y1 to the power of 16. Oh, that's not the same at all. So maybe we try B, which we know is the correct answer, but let's pretend we were actually doing this on a test. We get 9 over 7, and we get the same answer, 86.13. And these are going to be the same no matter what x and y are, as long as we don't break the rules of the universe, which I don't think is possible in this question. Typically for these types of things, you wouldn't want to do 0, because 0 creates sort of an ambiguity where we could put in the wrong answer. So let's try D, 63, power 63, and we get 0. So don't be deceived. I like to put very random numbers so we can, yeah, they're different. So 0 is where you could get into some trouble for these exponential questions. Question 17 says the population of city A increased by 7% from 2015 to 2016. If the 2016 population is k times the 2015 population, what is the value of k? So this is a nice system of equations problem. Really anything where we see more than one piece of information is a system of equations problem, but sometimes we don't like to set it up that way because there's a faster way to do it. So in this case, we can write our system of equation. Let's say the population in city A in 2015 is, we'll just call it A15, and similarly the population of city A in 2016 will be sub 16. So we'll say it increased by 7% from 2015 to 2016. So that means that in 2016 it's bigger. So A sub 16 is 7% greater than A sub 15, which we can just get by using the increase by percent formula, which is just 1 plus 7%. So this is something when you increase by a certain percent. So in this case, 7%, you take the original number and you multiply it by 1 plus that amount of percent you're increasing. There's a huge difference between 7% of and increasing by 7%. So that is something you have to be careful about. And then the second equation says if the population in 2016 is k times the population in 2015, what is the value of k? And I know some of you may be screaming at me, oh my gosh, you've taken so long to do this simple question. Well, I'm just writing down the expression, and I'm trying to explain the problem as I do so. Now, here's where the solution will actually start. If we set up the system of equations, we don't even need to do all this writing down. We can sort of just read it off from the problem, but I just wanted to write it down in case. We can go A sub 16. You can get the sub just by pressing shift minus, and we'll go equals A15, 1 plus 7 over 100, and also A sub 16 equals k times A15. What is the value of k? Well, this is a case where we have to be very concerned. Now, yes, it might look like k is right here and you might have your answers done, and in this case it is, but the two biggest things you need to look out for when you're doing a system of equations in Desmos is the RMSE equals 0, and you have the same number of unknowns as equations. In this case, we have more unknowns than equations. We have 3 unknowns and 2 equations, which is bad. There can be a lot of different reasons why you might have this. Sometimes, and in this case, that reason is not because we forgot to put information in there, but because one of the numbers, one of the constants doesn't matter. So if we're solving for k, we obviously know that k matters, but maybe the other 2 don't really matter. So let's try. Let's get rid of A sub 16 by adding a slider. So if we go 1 and we sort of scroll it up and down, we see that k stays the same, which means that it is one of the cases where this doesn't matter. And if we do the same thing for a sub 15, k stays the same. So that's something that is just generally good practice. If you have more unknowns than equations, sometimes you can add a slider for a number that you're not solving for, just to make sure that that k stays the same. Question 18 says, which of the following systems of linear equations has no solution? So when you have no solution, that means the lines are parallel. Parallel lines have the same slope. So really what the question is asking is, which of these linear equations has the same slope? And do we really need to graph it? Absolutely not. No, this is so much faster if we just look at and see which one has the same slope, but different y-intercept, right? Because just because they have the same slope doesn't necessarily mean they have no solution. They could have infinite solution. So in A, we'll see that a horizontal and vertical line, we can graph it if we truly desire. X equals 3 and y equals 5. They do have one solution. With B, we see that they have a different slope. So we do not need to graph it at all, but I will. And we see that they have one solution right here at y equals 0. And in C, we see they have the same slope and different y-intercepts, which is the perfect requirement for having no solutions. And if we graph it, we will see that this is the case. Y equals 16, x plus 19. These are parallel lines, which means they have no solution. The slope is the same. The slope is the coefficient of x is the same. In question 19, we're told the first number of a sequence is 9. Each term after the first is 4 times the preceding term. If w represents the nth term of the sequence, which equation gives w in terms of n? So there can be a way to do this by hand, and there also is a way to do this with Desmos. And what do you think I'm going to do? Yeah, probably the Desmos way. I'm going to make a table, and we're going to call this n and this w. And so n is 1, 2, 3, 4. N is just the number of the term we are in the sequence. And so we see that when n is 1, the first term, w, will be 9. And then each term after that is 4 times the preceding term. So we get 4 times 9. And then 4 times 4 times 9. And so on and so forth. Really, we don't need more than that, because what are we solving for? We're just solving for 2 unknowns, because this is an exponential equation. What we can do is say w is a times b to the n. And we get values. A is 2.25 and b equals 4. And we see that it's not an answer choice. So we might be really frightened. Oh my gosh, what's wrong? Well, no, this is a correct answer, but it's just not the answer that the SAT wanted. So we can see if we look at answer choices A through D, they give us the option of adding a n minus 1. And so what happens if we plug that in? Well, we have to use a parentheses. But if we do n minus 1, suddenly, oh, okay, we can do whatever we want with the exponent up here. It just adjusts the way that we look at A and B. So both of these are perfectly valid ways of writing the same expression. It just changes the number of A. The growth factor will stay the same, but when we add a minus 1 to the exponent, it changes what A is. So we can see that the answer is 9 times 4 to the power of n minus 1, which is D. Really, we don't even need this third point. We just need 2 points, because each point is an equation. 2 equations, 2 unknowns, bada boom, bada bang. In question number 20, we're told the minimum value of x is 12 less than 6 times another number n. Which inequality shows the possible values of x? So this is a tricky one to understand. You have to be very careful with how they word this. What I want to do is I want to think of it not as an inequality just yet, but what if they're just equal? So I can go x equals 12 less than 6 times another n. When they say 12 less than a certain number, I always put that at the end, because 12 less than just means whatever it's less than and then minus 12. So I'm going to do 6 times n minus 12. And that's the best way to represent 12 less than 6 times n. So we know we're dealing with the format 6n minus 12, which is going to be either A or B. It's just which way is the inequality facing. Well, we're told the minimum value of x is 6n minus 12. That means that x can be as big as we want. We just know the minimum value. So A or B, which one tells us that x can be super, super big, like it doesn't matter how big it is? That's going to be B. So unless you've done a lot of these problems, it can be a little bit difficult to know just off the top of your head which way the inequality sign faces. So sometimes you just got to think, oh, if we're told the minimum value of x, that means that there's only a minimum. There's no maximum. X can be as big as we want. And by common sense, that would mean B is the correct answer because that sets a limit for how small x can be, but not a limit for how big it can be. In this question, it says the side lengths of right triangle RST are given. Triangle RST is similar to triangle UVW, where S corresponds to V and T corresponds to W. What is the value of tangent of W? Okay, so for this one, we can start by just drawing the triangle RST. So we're told it's a right triangle, so it looks like something like this, because that's how right triangles look. And we know the longest length is 52. The shortest length is 20. And the last one is 48. Okay, so looking at the legs, the letter that shares the legs, 48 and 20 is going to be S. So we know that S is the intersection of the legs. And the shortest side, SR or RS, means that R is going to be here and then T is right here. So here is our triangle RST. And we're told there's a second triangle that is UVW. And it's similar. So similar means that all of the angles are the same, but the side lengths are just proportionally different. So I'm going to make this one tinier. So that is our UVW, where S corresponds to V. So S is in the same spot as V. T is in the same spot as W. And we can just assume that U is in the same spot as R, because that's the only spot left. So this is a right triangle, so we can go ahead and draw a little square right here. And the question is asking us for the value of tangent of W. We know that these two triangles are similar, which means all the angles are similar. So this angle, T, is going to be the exact same, congruent to angle W. Angle R is going to be congruent to angle U. So the tangent of an angle T is going to be equal to the tangent of angle W, just like the sine or cosine of angle T, S, or R is going to be equal to the cosine or sine of W, V, or U, because it's the exact same angle. So really, when they're asking for the tan of W, they're asking for the tangent of T. And so if we remember our sine, cosine, and tangent being so ka toa, which means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, then we can just figure out that the tangent of both T and W is opposite over adjacent. So when we're looking at this right triangle, the opposite of T is 20, and the adjacent of T is 48. So it's as simple as just 20 over 48, which is, if we click the fraction bar, 5/12, which is the answer choice B. This question says the graph of 9x minus 10y is equal to 19 is translated down 4 units in the xy plane. What is the x-coordinate of the x-intercept of the resulting graph? So there are two different ways we can do this problem. Both of them will take equally as long, and it's just different ways of thinking about it. So the first way will be doing 9x minus 10y equals 19. And this is the original graph that we're given, the original line. And the question is asking us to translate it down 4 units. So what that means is just moving this line and imagining it to go down 4 units. So what's pretty neat about any function is if you want to translate it up or down or left or right, what you can do is just put a parentheses around the variable. So if we're trying to move it up or down, that's changing the y value. If we were moving it left or right, we would be changing the x value. And since we're trying to move it down, we actually sort of do the opposite of what we might think. So we add to y to move it down. And that will give us the graph that we're trying to look at. So it's really fast with Desmos. We can just put parentheses and add 4. we just take the original variable. So if we're translating, up and down, we take y, and we just substitute y plus 4 in to move it down. So now we can press this purple to hide it, and we're looking at the orange line. And the question now is asking, what is the x-coordinate of the x-intercept? So we find the x-intercept, we can just click on it, and the x-coordinate is 6.55555555 repeating. And that is the correct answer to this problem. This question says there are 55 students in a Spanish club. A sample of the Spanish club students was selected at random and asked whether they intend to enroll in a new study program. Of those surveyed, 20% responded said they intend to enroll in the study program. Based on the survey, which of the following is the best estimate of the total number of Spanish club students who intend to enroll in the study program? So it sort of goes without saying that if we take a random sample of the Spanish club, then that's going to be, a good estimate of the total number of Spanish club students. They're not testing us on like that advanced statistics, right? So we're just going to assume that a random sample sort of is the same percentage as the entire population. So it says there are 55 students in the entire Spanish club, and 20% of them are going to enroll or intend to enroll in the study program. So it's really as simple as just saying 20% of the 55 students intend to enroll. So the correct answer would be A. This question says, a machine makes large boxes or small boxes, one at a time, for a total of 700 minutes each day. It takes the machine 10 minutes to make a large box, or 5 minutes to make a small box. Which equation represents the possible number of large boxes X and small boxes Y the machine can make a day? So we know this machine runs for exactly 700 minutes each day. So the total time it's making these boxes has to add up to 700. So we can say the time for like a large box plus the time for a small box equals 700. And the question tells us how much time it takes to make a long box or a large box and how much time it takes to make a small box. It tells us it makes a large box in 10 minutes. So the time it takes to make all of its large boxes is just going to be 10 minutes times the amount of large boxes that it makes. And similarly for the small boxes, it's going to be 5 minutes times the number of small boxes it makes. And then the question just says that X is large boxes and Y is small boxes. So Y is going to be our small boxes and X is going to be our large boxes. And then the correct answer that this corresponds to is B, because 10x plus 5y equals 700. This question gives us a scatter plot, and it says the scatter plot shows the relationship between the two variables X and Y. A line of best fit is also shown. So a line of best fit basically just means the line that gets as close as it can to all of the points in a scatter plot. It doesn't necessarily go through all the lines, it just gets as close as it can to trying to fit a model of what the lines sort of look like, or what the dots sort of look like. And luckily for us, it's multiple choice. And what's neat about this multiple choice is that we can sort of just check to see if the y-intercept is negative or positive, and then if the slope is negative or positive, because it turns out that there's only one answer choice for each possibility of positive or negative slope and y-intercept. So we don't even have to worry about the numbers. So when I look at this line, I see that it has a y-intercept that is positive and a slope that is negative. And there's only one answer choice that corresponds to that. It's B, y equals 13.5 minus 0.8x. This question gives us a line, and it says the point with coordinates d, 4 lies on the line shown. What is the value of d? So what we can do is, there are technically more mathematically sound ways to do this, but I care about sort of speed, I guess, for this question because it's really simple. So what I can do is I can just say, okay, we have the point 0, 7, and I also have the point 8, 0. And if I click and hold this purple right here, I can just toggle on lines. So now what I can do is I can say, okay, well, I'm wanting to know what the x value is when the y value is 4, because that's what the point d, 4 is. So I'm just going to go y equals 4. And it looks like the x value, it does not intersect. It would intersect if we made this like an actual graph line. But it looks like, all the answer choices are going to be fractions. So what you can do to make this work, of course, this only works because it's multiple choice, is we can just go d, 4, and then we add a slider for d, and we just test the possible answer choices. So A is 7/2, which is not correct. Of course, this is very jank. I typically don't like doing this. It only works because this is multiple choice. I would not do this if it were not multiple choice. It's a horrible way because then you would have to try to slide it and get it to fit right on here, which is not good. So the second choice is 26 over 7. And that does not look right at all either. And option C is 24 over 7. And that looks exactly right. However, it could be deceiving us just a little bit. So I'm just going to try the last one to make sure. 27 over 8. Yeah, and that is off. So the correct answer would just be 24 over 7. If we wanted to do this with a better method, we can. So what we can do is we can say, okay, we have a line, f of x equals mx plus b. And we know that it goes through the 2 points, 0, 8, and f of 0 is 7, and f of 8 is 0. So it goes through the points 0, 7, and 8, 0. So now we have this line right here. And then we can say f of d is equal to 4. And it tells us what d is. D is, we click on the fraction bar, 24 over 7. So this is the ideal way to do the question because it works no matter whether it's multiple choice or not, and it's just a lot more sound. It's good Desmos practice. It doesn't involve trying to look at something. I don't typically like, trying to get as close as possible or trying to be precise or having to zoom in. Those are all sort of bad Desmos techniques. This one is going to be the best. Okay, this question is great for Desmos. It says that for the quadratic function f, the table shows 3 values of x and their corresponding values of f of x. Which equation defines f? So if you remember back to my second video, I talk about how a point in a graph represents an equation. And I also talk about how we like to have the same amount of equations as we do unknowns, because that allows us to solve for all of our unknowns. So it looks like this table is just perfect, right? Because we have a quadratic. We know quadratic is in the form ax squared plus bx plus c. That means there's a, b, and c. That's 3 unknowns. And the table is giving us 3 points. So this works perfectly. So what we can do is we can put in all of our x values, -1, 0, 1. And we can say that f of -1 is 10, f of 0 is 14, and f of 1 is 20. And it looks like, if we want to zoom out, this just works perfectly. And it's as simple as that. So a is 1, b is 5, and c is 14. And that corresponds to d. F of x equals x squared plus 5x plus 14. So this one is Desmos juice right here. The function f is defined by f of x equals x plus 15 divided by 5. And we know that f of a is 10. So what is the value of a? Well, it's 35. And it's simple as that. So in this question, it says, in the figure, lines m and n are parallel. If x equals 6k plus 13 and y equals 8k minus 29, what is the value of z? So if we look at this question, we can try to figure out how x, y, and z relate. So I know that x, and I'm using x1 because you can't use x or y, so I'm using x1 and y1, and I'll just use z1 to stay consistent with the format, but you could use z if you wanted to. You can just refer back to my first video. But we know that x1 is equal to y1. That's something that we know. We also know that x1 is equal to 180 minus z1. And this is because if we draw our transversal lines, we label it m and n, and this is y, and this is x, and this is z, we know that by corresponding angles, this is also z. And since m is a straight line, we know that x plus z equals 180. So that means that x equals 180 minus z. And that's where we're getting this equation from. So now it's just a matter of solving for z because we're given some information. So if we look at it right now, we have 1, 2, 3. 3 unknowns, but only 2 equations. What we're going to do is we're going to add k, so we're going to add 1 more unknown. However, we're going to add 2 more equations. So what we can do is we can say x1 is 6k plus 13, and y1 is 8k minus 29. And it's giving us an error because it doesn't like that we've defined x in more than one place. So it's actually a simple fix. We can just switch z and x. So we say that z1 is 180 minus x1. And boom, now it works. The value of z is 41. So the correct answer is C. Regression will sometimes give you errors like that. You know, whether it's you can't have a list inside of a list, or you've defined this in too many spots, or all sorts of things you can get errors from. But there's usually a fix that you can do to get around it. Looking at this, it looks a little bit unnecessarily big, right? We have 4 equations. We have 2 inside of the regression, and we have 2 up here. So there's a way to simplify it. So first of all, we could take out this x equals y, and we could just say that 6k plus 13 is equal to 8k minus 29. And we could say that x1 is equal to 6k plus 13. And then we get the same answer with a little bit less annoying work. But it's really whatever you prefer. The first way is a little bit longer, but we're only typing in exactly what we're given in the problem. This one, we're doing a little bit of rearranging ourselves just to shorten how much we have to type. So it's up to you. In this next question, we're told that line P is defined by 2y plus 18x equals 9. And we're told that line R is perpendicular to line P in the xy plane. That's just a fancy way of saying in this plane right here, this 2D plane. It sort of doesn't really add much to the problem. What is the slope of line R? So we could do this 2 different ways. Like, one way is sort of just the quick way, not paying attention to anything. And the second way is like a little bit more mathematical. So I probably would just do the first way, but we can do the second way after the first way. Okay, so this first way is just looking at it and comparing results. So we could just go y equals mx plus, and then the y-intercept doesn't matter at all. So we could just go like 2, like it really doesn't matter. And then we just test the different values of slopes. So we could say -9. Does that look parallel? No, that doesn't, sorry, does that look perpendicular? No, it looks parallel. And we could go -1/9. Does that look perpendicular? Almost, but not quite. What about 1/9? Oh, yeah, that looks perpendicular, but because we're sort of doing an eyeball check, we want to go through all the answers. Does 9 look perpendicular? No. So it's C. So sure, you could do it this way. Or if you want, we could do it a little bit more mathematically. If we're given the format AY plus BX equals C, like we are in this case right here, we know that the slope is going to be -b/a. And that's not something you have to memorize because it's really as simple as just rearranging it. So if we subtract bx on both sides, we're given -bx plus c. And then if we divide a on both sides, then we're given y equals -b/a x plus c/a. And that sort of just looks like y equals mx plus b, where this is m, so the slope is -b/a. So we know that -18/2 is our slope. So -9 is our slope. And if you know anything about lines in the xy plane, then you should know that the slope of 2 perpendicular lines are negative reciprocals of each other. So the reciprocal of -9 is -1/9. The reciprocal is just 1 over whatever you're looking at. And then the negative reciprocal is just 1/9. So that's the mathematical way. Yeah, it's not really required of Desmos. You could sort of just look at this problem and do it in your head. But, yep, it's a pretty simple problem. This next question says, a sample of oak has a density of 807 kilograms per cubic meter. The sample is in the shape of a cube, where each cube has a length of 0.9 meters. To the nearest whole number, what is the mass in kilograms of the sample? So we know density is mass over volume. That's something we should remember. And we're actually told what this mass and volume is, well, at least what the units are. We're told that it's the density, so we can just call it D, is 807 kilograms per cubic meter, so per meter cubed. And we can just add a 1 right here, because 807 divided by 1 is still 807. And it says that the sample is in the shape of a cube, where each edge has a length of 0.9 meters. So it turns out, if we have a cube, whoop-de-doo, and we want to find the volume, we can sort of just cube the side length. So our volume equals 0.9 meters cubed. it looks like we're solving for the mass, which is pretty easy because we know that density is just mass over volume. And we have volume and we have density. So we're solving for the unknown. Okay, so we can do the rest in Desmos. I would do all the unit analysis, but it doesn't really matter. We know that it works out. If you want to make sure the units work out, you can do it by hand. We get volume equals 0.9 cubed, meters cubed, and we get density is 807. And we can just go density is mass over volume. And we get a mass of 588. Now, one thing you do want to check is making sure the units are all correct. So we've used kilograms and meters. And so I want to look through the problem and just make sure they don't use anything other than kilograms and meters in the entire question, which it does not look like they do. They're asking for the mass also in kilograms. So that's important to check. The nearest whole number is just 588, which means the correct answer is A. This question says the function P models the population in thousands of a certain city T years after 2005. According to the model, the population is predicted to increase by N% every 18 months. What is the value of N? So this problem, it does look a little bit tricky. It might scare you because a lot of times people are not familiar with exponential functions. But don't worry at all because we can do this one pretty easily with Desmos. So we are told what P is. And we can actually name this function anything. It doesn't have to be f of x. We can name it P of t. You can literally choose any letter outside of the parentheses to name your function, and any letter inside of the parentheses to be the variable of the function. So P of t is 290 times 1.04 to the power of, and since we have a sort of a complex exponent, we want to make sure to use parentheses, and that'll allow us to type more inside the parentheses. So 4 over 6 t. Now it's saying the population is predicted to increase by N% every 18 months. So one thing that you really need to know for the SAT is percent formulas. So percent of is way different than percent increase. Percent of is very easy. So, P percent of N, and I just use N for a number, is just going to be P percent. Percent is just divided by 100. And it's actually cool that they use that word because per means divide. Like miles per hour is miles divided by hour. And cent means 100, like centipede or century. So percent literally means divided by 100. So it's easy to remember. So P percent of means times, and N. And that's why this percent is really easy. P percent of N is P divided by 100 times N. Now, a little bit trickier, just a teensy bit, and not really, but very important difference is percent increase or percent decrease. And there's sort of two different formulas, but they relate completely. You can get one from the other, but it's two formulas that I like to memorize. And you don't even necessarily have to memorize if you understand how it works. But a percent increase, for example, if I'm going to increase in P percent, what I'm going to do is I'm just going to take P percent increase of N is equal to N times 1 plus P percent. And so what that sort of looks like to understand why we even use this formula is if we distribute, we get N plus P over 100 times N. And, well, what do we know? This P over 100 times N is just P percent of N. So we're just taking P percent of N and we're adding it to our original value N. And that's all percent increase is. It's just percent of, but we're adding it to our original value of N. So it's really not that complicated. That's one formula that you can use. However, another one that you can also use is our new value. I'm going to change this N number to O, or our original value. So our new value equals our original value times 1 plus P percent. And that's for percent increase. So for percent decrease, it's N equals original value times 1 minus P percent. And the other formula that I was talking about, you don't really, as long as you know regression, you actually don't really need to know it anymore because regression sort of removes any reason to care about switching up equations. But, for fun, you can memorize it. So P equals new minus old over old times 100. and that will give you your percent increase. And if you get a negative number, then it's just your percent decrease. But you rarely really need to know this formula. It's not really important. So because regression allows us to just use the same format to solve for anything. So using that formula with this problem, we can just say that it's going to increase by n% every 18 months. So because this is an exponential function, as we can see if we zoom way out, that means that this statement that it gives us, that it increases by n% every 18 months, is true no matter where we start. So if I choose a random value, we start at maybe any time we want. So I can just say A to denote any time. It doesn't really matter. So if I make a slider like P of 1, that means that 1 year after 2005, our population is at 297, right? So it doesn't matter what our A is, but we'll call P of A our original value. So what's our value 18 months later? Well, we have to remember that this is in years, T years after 2005. So what is 18 months in years? Well, that's just 1.5, or if you want to do it in Desmos, 1.5. 18 divided by 12 months in a year, 1.5 years. So our new value, our new population is A plus 1.5. And that's going to be equal to our original value, P of A, times 1 plus n%. And we can move around the slider A to see that it doesn't really matter where we start our counting. It's going to be true no matter what A is. N equals 4. And so that means the correct answer is C. In this question, it says in the given equation, K and N are constants, and N is greater than 1. The equation has no solution. What is the value of K? Because this equation has no solution, we know that the two lines, which we'll see they're actually, we're just comparing two lines, are going to be parallel. Whenever we're given equations like this, where we have x's on both sides, you almost always want to change it into y equals the left side and y equals the right side. So on the left side, we're given y equals 2 times kx minus n. And the right side, we're given y equals negative 28 over 15 minus 36 over 19. So we're looking at these two different lines. And actually, there's multiple ways to do this question. And I think this is the first time I've done this on my channel. Of course, I've been teaching this method for almost a year now. I still have not brought it up on this channel, which is crazy. So I want to do it the simple way first, and then I want to introduce this new technique. So the first way, of course, is just seeing how simple of a setup this question is. And, oops, I meant to say negative 28 over 15x. So, of course, we know that if two lines have no solutions, then they are parallel. And parallel lines have the same slope. So if we distribute this out, this top one, we get 2 times kx minus 2 times n. So then we know that 2k is equal to negative 28 over 15. So k is, and we hit the fraction bar, negative 14 over 15. Now, sometimes we're given two lines and they're not as easy to find out what the slope is. In this case, it's very easy because we already have it in y equals mx plus b form, but sometimes we actually don't. So a super clever way to do these types of problems, and I'm sure we'll encounter more later on, is by actually setting them up as a system of equations. So y1, comma y1, and 2kx1 plus 2n, comma negative 28 over 15 x1 minus 36 over 19. And so now we see that they intersect, and that makes sense though, because this regression is telling the lines to intersect. In fact, if you look at what the x value and the y value are, I don't know why it looked like that before. I just made a slider and deleted it, and now it's correct. So if you look at the regression, it tells us what our x and y values are of the intersection point. So x is 1, y equals negative 3.7, whatever. And that intersection point is actually what the regression tells us. But that's what we're looking for. We're looking for 0 intersections. So watch this. I want to introduce a couple terms. So like a constant is a number that's not a variable. So for example, this 2 is a constant. This negative 20 over 15 is a constant. 36 over 19 is a constant. Actually, k is also a constant. N is also a constant because those represent numbers. So the only things in this question that are not constants are y1 and x1, or x and y. Now a term. So a term is anything in an equation that's separated by plus or minus or equal sign. So for example, a y is a term, this negative 28 over 15x is a term, this negative 36 over 19 is a term. And so now if we combine those two words, a constant term is an entire term that consists only of constants. So this is not a constant term. This is not a constant term. 2kx1 is not a constant term. 2n is a constant term. Negative 28 over 15x1 is not a constant term because it has an x1. And negative 36 over 19 is a constant term. In this method, what we do is we just replace all constant terms with 0. So nope, 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 yes. So we turn this into 0. Nope, yes, and we turn this into 0. And it's giving us an error because it doesn't, like that we don't have n, but really we don't even need it. But if we wanted to make it not give us an error, we could just put like 0n. But yes, now we look at this, we see that these lines are parallel. So it's crazy how this works. I'm not going to go super in detail of how it works. Basically, just think of it as when taking out the constant terms, we sort of get rid of any thought of the y-intercept, and we basically tell this system of equations, hey, go ahead and make those slopes equal to each other, because the coefficients of x and y, so this is a coefficient of x, this is a coefficient of x, this is a coefficient of, a 1 secret, a hidden coefficient of y and y, those are all being set equal to each other. So that's basically how it works. It's really nice, and now we can just type in k. So, of course, don't use it for this question because it's already set up for us. But if you're ever, in a situation where it's not as easy as just looking at the slope, then this method works great, and I'm sure we'll come across it again. The next question says, a gift shop buys souvenirs at a wholesale price of $7 each and resells them each at a retail price that is 290% of the wholesale price. At the end of the season, any remaining souvenirs are marked at a discounted price that is 80% off the retail price. What is the discounted price of each remaining souvenir in dollars? So this item, the souvenir, goes through a lot of different sales changes, but we can sort of just track them. So first it starts at 7, and we resale them for a retail price that is 290% of that wholesale price. So if we really, really want to track it, we would be like, okay, wholesale price, WS, is $7. And then retail price is 290% of wholesale price. This is overkill, complete overkill, but we're going to do it anyways. At the end of the season, any remaining souvenirs are marked at discounted price. So discounted price is 80% off the retail price. Now, 80% off, how do we even write that in Desmos? Well, it turns out that off and on are opposites. So similarly, 100 minus the percent off is the percent on, or percent of. So 100 minus 80%, or 100% minus 80% is 20%. So 20% of is the same as 80% off. So 20% of the retail price is our discounted price. What is the discounted price of each remaining souvenir in dollars? And the answer is 4.06. Now, of course, do we have to do all 3 different lines? No, it's pretty simple to just go, well, we start with $7, and then we're taking 290% of that, and we're then doing 20% of that. And that's simple too. But, whatever works for you. Now, why it all works and I'm not worried at all is because all of them are just percent of, which just looks like a multiplication. So there's no problem or worry or concern of order of operations here. Or else it would probably be a little more tempting to use that first method where we separate everything out. In this question, it says, in the given equation, c is a constant. The equation has no real solutions if c is greater than n. What is the least possible value of n? So this question is actually a little bit funny, and it's written poorly. I'm surprised they haven't changed it yet, because the only time in this problem that we're told about n is in that second sentence, where it says c is greater than n. This is the only information that we have about n. Now, what's funny about this is that means that n can be anything that's less than c. So, for example, what if, let's pick any random number for c. Let's say c is 100. That means that n can be anything less than 100. And the problem is that the question is asking us for the least possible value of n, which means that really there is no bottom limit. There's no least possible value because n can be as little as you want. Look at this graph. So if we just say n is our x value, see what I mean? No matter what c is, it's sort of c just doesn't really matter. We're still going to get this super far left inequality where we basically can go to negative infinity. It doesn't matter what c is. So what's the purpose of solving for c, right? Well, yeah, that's the question is a little bit stupid, but let's just try to solve for c. What we're going to do to make this problem actually doable is we're going to assume actually that the question instead says that what is the greatest possible value of n, assuming that n is an integer. And these are the two pieces of information that we need to change a little bit to make this question solvable. So this one uses the discriminant. The discriminant is part of the quadratic formula, which quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And the discriminant is this part inside of here. And why this is important is because if we take the square root of a negative number, then we get an imaginary number, which you don't really need to know about in SAT. But if you don't know what an imaginary number is yet, then it basically just doesn't work. We can't do this. And so there's no solutions if whatever's inside of this square root is negative. So that's why the discriminant matters for us. We want to know, when is this discriminant negative? Because the question is asking, there's no real solutions. Luckily, we know what a and b is. We just don't know what c is. So we're going to plug in a and b right here. So b is going to be negative 34. So negative 34 squared. And then minus 4ac. Minus 4, a is 1. And then c is the number that we don't know. If we do a little bit of Desmos, we get 34 squared is 1,156. And we get minus 4c. And this is going to be a negative number, which means it's less than 0. So with a little bit of rearranging, we'll get 1156 is less than 4c. And 1156 divided by 4 is 289. So 289 is less than c. And so that means that the greatest possible value for n would be 289 because c has to be greater than 289. And so the greatest possible value of n would be 289. This question says, dataset A consists of the heights of 75 buildings and has a mean of 32 meters. Dataset B consists of heights of 50 buildings and has a mean of 62 meters. Dataset C contains the heights of 125 buildings from dataset A and dataset B. What is the mean of dataset C? So dataset C is just taking all the buildings from A and all the buildings of B and combining them together. What I want to do is sort of look at how that might work, because it's not as simple as just taking the mean of 32 and 62 meters, because they have a different amount of buildings inside of them. So the mean of A is going to be the sum. So I'm just going to use like this to mean sum. The sum of all the numbers inside of A divided by the count of A. We'll just use number of A. And similarly for dataset B, the mean of dataset B is the sum of B over the number of B. So that means the mean of C, which we're trying to solve for, is the sum of all the numbers inside of C divided by the number of C. We actually know a lot of stuff. Well, we know that this right here is 75. There's 75 buildings. We know this right here, this mean, is actually 32 meters. The mean of B is 62 meters with 50 buildings. So this is 50. And we actually know this right here too. We know that the number of C is 125. And also we know one more thing. We know that the sum of all the numbers in C is the same as the sum of all the values inside of A plus the sum of all the values inside of B. And that will give us the sum of all the values inside of C because we're just combining A and B. So that equals the sum of A plus the sum of all the numbers in B. And I'm using this notation like just very, very loosely. Like, don't get scared because I'm using some wacky symbol. I'm just representing the sum. You don't even have to think about it this way. Like, we can just skip over this entire step. I'm just sort of explaining how this is going to look. Why I write all this out is because if we look at it, we actually can multiply the number of A over to the other side, and similarly multiply the number of B over to the other side. So we can get what the sum of all the numbers inside of A is, and we can get what the sum of all the numbers inside of B is. So I'll just call this right here. From now on, I'm going to call the sum of all the numbers inside of A just called A. So A is 32 times 75. And that's what happens if we add up all the meters of all the buildings inside of A, is 2,400 meters is the combined meters. And so for B, it's going to be 62 times 50. And then C is just A plus B. So now it's as simple as getting the mean is C divided by 125. So it's 44. This is an example of like a weighted mean where you have to weigh each thing according to how many items are inside of it. So if we want, we can sort of look at it a different way. This might not help some of you, but it might help some of you. So I'm going to just show it anyways. We could think about it by percentages of the total number of C. What percent comes from A? So if we look at it, we have 125 total, and we get 75 of those 125 from A. So we get 60% of our mean is going to be from A, and we're going to get 50 divided by 125. So 40%, of course, fixed. It's going to be 40% because that has to add up to 100. 40% of our mean from B. So 60% of A plus 40% of B. And we know that we're just going to put in our mean. So this time A and B means our mean, not the sum of all the numbers inside. So the mean of A is 32, and the mean of B is 62. And that gives us the same number. So you can think about it either way, but it's just a weighted mean. So A is weighted 60% and B is weighted 40%, whichever way you'd like to do. This question says the expression 4x squared plus bx minus 45, where b is a constant, can be rewritten as hx plus k times x plus j, where h, k, and j are integer constants. Which of the following must be an integer? So this one sort of plays on what happens when we distribute this all out. So it's not really Desmosable. I mean, you could do it in Desmos, but like it just makes a lot more sense to even do it in your head. But I'm going to write it out just so you can sort of see how it works. But don't even write this one out. Just do it in your head. So how this problem looks, hx plus k and x plus j. When we distribute it out, we FOIL. So we're going to get first is hx squared. Our outsides are going to be hjx. Our insides are going to be kx. And our last is going to be kj. So we know that h, k, and j, so every constant in here is an integer. We can also combine this right here, this b section, into hj plus kx, and that's just by factoring it out. So our full quadratic would be hx squared plus hj plus k times x plus kj. Yeah, so of course now we're looking at our entire quadratic, and we don't have to go this far. But so h is going to be 4 for 4x squared. hj plus k is going to be b, and kj is going to be negative 45. And if we look at it, answer choice A and B, like that's like why are we even combining h, k, and b? Like that doesn't make sense. Like let's just look at C and D. How is h, our A term, even related to 45? Our C term, it's not at all. Now, however, D is 45 divided by k an integer. Well, I know that k times j equals 45. So 45 divided by k, or well, really negative 45, right? So j equals negative 45 divided by k. And so 45 divided by k is just negative j. And if j is an integer, that means that negative j is an integer. So it's really simple as that. Like, I recognize this problem, pretty immediately. When I look at this factored expression, I know that we're going to be multiplying k and j together. And I know that when we multiply them together, I'm going to get negative 45. So, of course, I know that 45 divided by one of the factors, k and j are the factors, 45 is the product. Two factors equals a product when you multiply them together. If I divide the product by a factor, then I'm going to get another factor. And they're all going to be integers. So that's how it's really easy to tell that D is the correct answer without even having to check anything else. Everything else is just completely unrelated. It's like combining A's, B's, and C's in ways that just don't always work out. This question says, in the given system of equations, A is a positive constant. The system has exactly one distinct real solution. What is the value of A? Cool. So just for funsies, we can put this into Desmos. And x squared plus 8x plus a. Yeah, so it looks like there's a certain value of a where it doesn't intersect at 2 points, but it only intersects at 1. So there's a pretty simple way of doing this one. It's especially very simple because this line is a horizontal line. And because this line is a horizontal line, it should make sense, if let's increase this to 30, that when it does intersect at exactly 1 point, which just so happened to be 14.5, however, sometimes the question will be an irrational number, which in that case, you don't want to use a slider. But we can see that when it does intersect at exactly 1 point, it's going to be at the vertex because of this horizontal line. And don't use a slider like I did. Like, really, really don't, because it may be an irrational number and it might be multiple choice and you might get it wrong. So what you can do is just simply turn this into a function. And then we say, okay, I want to tell Desmos that the y value of the vertex is at negative 1.5. I know the x value of the vertex is negative b over 2a. That's something that everybody should know. The x value of the vertex of a parabola is negative b over 2a, where this is your a value, this is your b value, and this is your c value. So it looks like our c value, well, that's what we're solving for. Our a value right here is 1, so 2 times 1. And our b value is 8. So we've just now figured out the x value of our vertex is negative 4. Well, the y value, and the entire reason why we added this function right here in the first place, if we can find the y value of any x value just by putting f of around our x value. Now, this is our y value of the vertex. And the y value equals negative 1.5. And Desmos just tells us now. So we can do 18, we can get our fraction 29 over 2, or 14.5, and this is so much better. So this is the way you want to do it. Okay, this question says the dot plot represents the 15 values in dataset A. Dataset B is created by adding 56 to each of the values in dataset A. Which of the following accurately compares the medians and the ranges of dataset A and B? So first I want to define what a range is, which most of you should know, but if you don't, that's okay. So the range is just equal to the maximum value minus the minimum value. So if we add 56 to each of these, then we get max plus 56 minus minimum plus 56. And that just turns out being the max minus the minimum plus 56 minus 56, which just cancels out. So the range is just going to be the same, no matter if we add 56 to all the values or not. However, the median is the number in the middle if we line them up in numerical order, in increasing order. And it looks like right now that would be probably 23 or 24. It doesn't really matter. However, if we added 56 to every single value, then it's going to be obviously greater because that 23 or 24 turns into 79 or 80. So the answer choice would be C. The median of dataset B is greater and the range is equal. Okay, this question is probably one of the first fun ones. Here's, I think, question 18 is where the problems get fun. So if you've just skipped here from the beginning, then yeah, let's have some fun. So this question says the rational function f is defined by an equation in the form of f of x equals a over x plus b, where a and b are constants. The partial graph of y equals f of x is shown. If g of x equals f of x plus 4, which equation could define function g? So a lot of people are intimidated by this question. In fact, I mean, it looks intimidating. I wouldn't want to do this by hand. However, Desmos makes this so easy, and this is why I love Desmos. So first of all, let's just go ahead and, like, whenever it gives you functions, it almost always makes it easier to just plug in those functions into Desmos, because then we can reference them whenever we want. We have to first define, then reference. So if we define them, then we're good to go. We're in the clear. We also know that g of x equals f of x plus 4. Looking at this partial, f of x is shown. So we need how many points? Well, we have 2 unknowns, so we need 2 equations. So 2 points. So we're going to just go ahead and put in 2 points to fully define our f of x. And the reason why it's giving us a warning is because we need to define a or b. Actually, in fact, we need to define both of them. So I'm going to look at where this partial graph perfectly intersects some lines, and I'm looking at some 2 nice juicy ones that are at -7, -2. I'm looking at another nice juicy one at -6 and -3. So now we can just try plugging in the answer choices. Answer choice A says 6 over x, and if we change this to green, we can see that the green does not equal red. If we try answer choice B, 6 over x plus 4, we can see that green does not equal red. But if we try answer choice C, 6 over x plus 8, then green does equal red. Now, because we are doing an eyeball test, I'm going to try all the answer choices, but I can already tell that D is wrong because x plus 4's cancel out, and it'll leave us with something that looks like a line. So we can tell that green is obviously not equal to red. So answer choice C is the correct answer. Okay, this question says, in the given equation, A and B are positive constants. The product of the solutions to the given equation is KAB, where K is a constant. What is the value of K? So this one is honestly not that tricky at all, as long as you know a couple parabola rules. So one we already used before. One of them looks like the x value of the vertex is -b over 2a. That's one you should know. That's the x value of the vertex. You know the discriminant is b squared minus 4ac. And we know the sum of the solutions is -b over a. And one more that we should know is the product of solutions. The product of solutions is super easy. It's c over a. And looking at our quadratic, our c is ab, and our a is 57. So our product of solutions is ab over 57. However, the problem tells us that the product of solutions is KAB. So KAB equals AB over 57. So we can use regression if we would like to, but we really don't need to. KAB is equal to AB over 57. So K is equal to 1 over 57. However, I want to note that we're solving technically for 3 unknowns here, which makes me a little bit uneasy. Well, it should make you uneasy if you have more unknowns than equations. So what I'm going to do is I'm going to just make sliders for everything that we're not solving for. So A is 1, B is 1, and as long as it's a correct setup, K should not change no matter what A and B are. And as you can see, it's the case. Now, if we make A equal to 0, then stuff goes berserk, so just try not making sliders go to 0. And if it's like an exponential, like, don't make it go to 1. Just pick random numbers. And yeah, so K stays the same, so we're good. This question says the graph of x squared plus x plus y squared plus y equals 199 over 2 in the xy plane is a circle. What is the length of the circle's radius? This one would be so annoying by hand. I'm so sorry for the people who did not have Desmos. But for us, we just sort of type it into Desmos. And while I'm typing this in, I want to say a lot of people are like, oh, College Board is saying that they're trying to make the SAT not Desmosable, right? Oh no. This is the type of question they're talking about. They're getting rid of like these type of questions, where the ones where you can like just plug it in. Like this doesn't require any regression. It doesn't require any like advanced knowledge. So as long as you know how to do the stuff that like I do with the questions that are like not as stupid easy as this, you're fine. You can still use Desmos for everything. They can't really make an SAT that you can't use Desmos for. So don't worry about that. So we can just find the diameter by like clicking these 2 points. So we see it goes all the way from negative 10.5 to 9.5. So we'll just do like 9.5 minus negative 10.5 to get 20. And that's our diameter. So our radius is just diameter divided by 2. So our radius is 10. So this one is a little bit more of a doozy. It says that 2 identical rectangular prisms each have a height of 90 centimeters. The base of each prism is a square, and the surface area of each prism is k centimeters squared. If the prisms are glued together along a square base, the resulting prism has a surface area of 92 over 47k centimeters squared. What is the side length in centimeters of each square base? Okay, so let's sort of like draw this out. So they each have a height of 90. So this is 90 and this is 90. And the base of each prism is a square. The surface area of each... Okay, so we don't know the side length right here, so we can just call this S. And the surface area is 92 over 47. Okay, so looks like we're solving for K, and we also have an unknown S. So we have 2 unknowns, so we need 2 equations. This should be pretty easy to find as long as we know what we're looking for. So first thing it tells us is the surface area of one prism is K. I'm already going to just put in our system of equations because I know we're going to have to. But the first one is K is equal to the surface area of 1. Well, if you know your surface area, then you can just plug in your formula. Or if not, we can just add up the surface area of each side. So I know I'm looking at 2 bases, one on top and one on bottom. So it's going to be side squared plus side squared. Those are our 2 bases. And then we have 4 of the, sides that wrap around. So each side is going to be 90 times S. And that's the surface area of 1. And we also were told that 92 over 47, K, is equal to the surface area of both of them combined. So that's just going to be, again, 2S squared. I'm going to put it together this time. The top and the bottom, plus 4 times 180 times S. And that should make sense because we're looking at them glued together. So they have a combined side height of 180, 90 times 2. Now, you'll see that we're getting 0 and 0. So this actually works, and Desmos is not smart enough to know that K and S can't be 0. So we have to tell them that. But watch what happens when we do that. If we say that K needs to be greater than 0, Desmos would rather pick this value, which is just extremely small, negative 10 to the power of negative 163, basically 0. It would rather just try to pick a number that's so close to 0, but technically being a smart little aleck, than try to find our correct value. Some tricks that I have are, I think, okay, which one is smaller, K or S? Because the smaller, for example, let me demonstrate right here. If we have like a number line where this is 0, like this is S and this is K, if we pick a number for this domain right here for it to be greater than, like let's just say we choose 1. If we say that S needs to be greater than 1, proportionally, this is a much bigger gap to go. So it's going to be a lot closer to S proportionally than if we were to say K. Because look at this jump right here. That's a huge jump to make relative to this little tiny one. So Desmos would rather be wrong. So I'm going to always sort of pick the one that's closer to 0. So I'm going to say S is greater than 0. And I don't expect it to change, but we'll see. Yeah, so it doesn't change. However, if I slowly start incrementing this up, we'll see when it starts to jump. So, it only took 1. So S is 8. See, K is much bigger. So for example, if we tried to take away this, and we said K is greater than 1, see how K is just wrong? And RMSE is telling us that it's wrong. It would rather just be wrong than have to jump all the way up to a 3,000. But if we choose S, then it gives us correct. Because it's fine with only jumping up 7. That's not a big deal at all. Yeah, so this one looks sort of challenging, but what's the goal of all geometry problems and a lot of the more advanced SAT questions in general is just to try to convert it into a system of equations. Okay, the last question says, in the xy plane, a parabola has a vertex 9, negative 14 and intersects the x-axis at 2 points. If the equation of a parabola is written in the form y equals ax squared plus bx plus c, where a, b, and c are constants, which of the following could be the value of a plus b plus c? So this one can be done many different ways. And I've done this one many different ways, but I think the best way to do this one is the one I'm about to do. So first, I want to go ahead and define this function, f of x equals ax squared plus bx plus c. And we're solving for 3 unknowns, a, b, and c. That will fully define the parabola. So I'm looking for 3 equations. Luckily, a vertex actually gives us 2 equations. Not only does it give us that the parabola intersects the point 9, negative 14, it also tells us that point is the vertex. So how we can put this into Desmos in a system of equations, which we'll go ahead and add, is by saying f of 9, f of our x value, equals our y value. And also that negative b over 2a is 9. So we already have 2 equations. And our last equation is going to be a plus b plus c. And I meant to put in negative 14. A plus b plus c equals, and then the question is asking which could be the value of a plus b plus c. So I don't know what the value of a plus b plus c is, so I'll put in whatever the value of a plus b plus c is. It is going to be our answer. So I can just put an answer right there. So our answer is going to be, and we'll try all the answer choices. So negative 23, let's try that out. So it looks like RMSE is basically 0, which means it's found a solution. And if we wiggle this, it'll be 0. So negative 23. Yeah, so RMSE is equal to 0, so it's found a solution. Here's our solution. So it's possible. You might be inclined to think, oh, this could be a value of a plus b plus c. However, if we read the problem carefully, we see that it says that this parabola intersects the x-axis at 2 points, which this parabola is not doing at all. But we can fix that. We can say that so A controls, actually, just watch what happens. Watch what A controls. So A controls the thinness and thickness of this parabola. It also controls whether it goes up or down. So if A is positive, then it makes the parabola get skinny and fat. If A is negative, then it does the exact same thing, except just upside down. So if we know that the parabola intersects the x-axis at 2 points, then we know that A has to be positive. So now let's try this again. Answer equals negative 23. And watch this. RMSE goes up. If RMSE is not 0, then it's not possible to find a solution to the system of equations. So this answer choice, negative 23, could not be a value of a plus b plus c. And we're looking for a value that could be the value of a plus b plus c. So we can just try a different value. Negative 19. RMSE is also not 0. So this could not be a value of a plus b plus c. Now watch what happens when we do negative 14. Negative 14, we get a really, really small value for RMSE. And I usually tell people if RMSE looks like this tiny, then it's basically 0. However, there's a bit of a problem. So if we do this question mathematically, which I don't want to do, but you can do it if you want to. I mean, it's not super hard, but it's just time consuming and it's a lot faster with Desmos. What you'll end up getting is that a plus b plus c has to be greater than negative 14. So when Desmos is trying to figure this out, what it actually does is it sets values for a, b, and c that make it so that a plus b plus c equals like negative 13.99999. Like I would put ... I would put ellipses, but technically that's not mathematically true. We'll just put like 8 right here. Okay, yeah, so that's what Desmos is setting a plus b plus c equal to. And so that's why the RMSE is not truly 0. And it is correct in saying that it's not 0. But this is one of the only cases. Usually if you see a really, really low number for a plus b plus c and you're not dealing with something like a limit, so this is called a hyperbolic limit. If you're not dealing with something like that, then you don't have to worry. So, and it makes it a lot more obvious too. If you were to check all 4 answer choices, even without knowing any of that, you don't have to know any of that. I think that you'd be pretty certain if you check D, negative 12, you'd see that this fits so much better. We see that it clearly intersects the x-axis at 2 points, and we see some nice numbers for A, B, and C, and this is the value of A plus B plus C is negative 12. Well, thank you very much for watching all the way through to the end, and hopefully I'll be able to be posting more videos soon. I had an amazing internship in New York City over the summer, and I just didn't have a lot of time to record. But yeah, feel free to leave any questions in the comments, or you can DM me on Discord. But yeah, until next time, see ya.